Good afternoon. We are going to take the notes for sections 6.5 and 6.6. And these sections of notes deal with properties of special parallelograms. So we're going to work with rhombuses, rectangles, and squares primarily, and see how they relate to parallelograms and some of the theorems and postulates that are unique to each of these figures. All right, Roman numeral 1, definitions of special parallelograms. Here we go. Number 1, definition of a rectangle is a quadrilateral or four-sided figure with 4 right angles. So in a rectangle, all 4 angles are right angles. And because all 4 angles are right angles, that means that opposite angles are congruent. And we have a theorem that says if opposite angles are congruent, then we have a parallelogram. So rectangles are also parallelograms, and all the theorems that go with parallelograms can be used with rectangles. Again, every rectangle is a parallelogram because both pairs of opposite angles are congruent. All right, definition number 2, rhombus. A rhombus is a quadrilateral with 4 congruent sides. So if this is a rhombus, all 4 sides are the same. Now you're going to notice that the angles are not the same. There are 2 that are tiny acute angles and 2 that are obtuse. So only the sides are the same. Now, we have a theorem for parallelograms that says if opposite sides are congruent, then it's a parallelogram. So every rhombus is a parallelogram because in a rhombus, both pairs of opposite sides are congruent, which make every rhombus a parallelogram, and you can use all your parallelogram theorems with a rhombus. Okay, number 3, definition of a square. A square is the most versatile shape by far. A square is a quadrilateral with 4 right angles, which means that a square is a rectangle. But a square also has 4 congruent sides, which means it is also a rhombus. Now, in a rectangle, 4 congruent sides, 1, 2, 3, 4. 4 congruent, that's 4 congruent angles, 4 congruent sides. And you can use any of your parallelogram theorems with this. If opposite sides are congruent, it's a parallelogram. So a square is a rectangle and a rhombus and a parallelogram. It's very flexible. And let's reinforce that. Flip the page just to make sure you've got it, because this is the most complicated figure. Every square is a rectangle because it has 4 right angles. 1, 2, 3, 4. A square is a rhombus because it has 4 congruent sides. A square is a parallelogram because both pairs of opposite angles are congruent. Okay, so those are our new figures. Let's get into some of the theorems. We're going to start with rectangle theorems. Theorem 618. If a parallelogram is a rectangle, then the diagonals are congruent. So the if is it's a rectangle, so 4 right angles. And if it's a rectangle, this theorem says automatically your diagonals are congruent. They're equal length. So AC is congruent to BD. That's our first theorem for a rectangle. Okay, our second one. This is actually the reverse of 618. 621 proves it's a rectangle. 618 starts with it being a rectangle. So 621 says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So the definition of a rectangle is 4 angles are 90 degrees. So in this one, we're not using the definition, we're using the fact that if you have a 4-sided figure, or actually a parallelogram, excuse me, if you have a parallelogram, so let's mark these parallel, top and bottom, left and right, and the diagonals are congruent. So AC is congruent to BD. So 2 things are true. It's a rectangle and the diagonals are congruent. If that's the case, the result is a rectangle, which means all 4 angles are 90 degrees. All right, so those are our 2 theorems for rectangles. Let's now go to the Rhombus Theorems, 616. If a parallelogram is a rhombus, then the diagonals are perpendicular bisectors. Perpendicular bisectors of each other. Okay, so the if it's a rhombus, and of course a rhombus is a quadrilateral with 4 congruent sides, if you know it's a rhombus, then when you draw in the 2 diagonals, not only do they bisect, so you have a short piece and a short piece, a long piece and a long piece, so not only do they bisect, they are actually perpendicular. So you get really nifty 4 right triangles. You can use Pythagorean Theorem with those. You can do all kinds of things with 4 right triangles. Okay, flip the page. That's our first rhombus theorem. Here's our next one, Theorem 617. If a parallelogram is a rhombus, then the diagonals bisect all 4 angles. So again, we're starting with a rhombus, so all 4 sides are the same. And if it is a rhombus, when you draw in the diagonals, not only do they bisect each other, they actually bisect the angles. Now, remember that the angles of a rhombus are related. Opposite angles are congruent. So when the diagonals bisect B and D, you're going to get 4 of the same angle. When you bisect A and C, you're going to get a different 4 pieces because angle A and angle C are the same. All right, Theorem 620. Here we go. If a diagonal, and notice it's a diagonal, so only one. If only one diagonal of a parallelogram bisects 2 angles of the parallelogram, then the parallelogram is a rhombus. So this one's kind of interesting. So we start with the parallelogram. So opposite sides are parallel. We only need one diagonal. If that one diagonal bisects B and D, and again, opposite angles are congruent, so you're getting 4 pieces there. If one diagonal bisects 2 angles, then you have a rhombus and all 4 sides are congruent. Now do notice that you have to start most of these with a parallelogram. All right, D, Theorem 619. If the diagonals, so we're talking 2 of them, if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So you've got a parallelogram here. So let's mark the sides parallel. If the diagonals are perpendicular, so when I draw in AC and BD, if those are perpendicular, then it's a rhombus, and all four sides are the same. So a rhombus has diagonals that are perpendicular. A kite has diagonals that are perpendicular. All right, flip the page. We're going to do some practice. Okay, so for these exercises, the given is that you have a rhombus. All right, so the first question, what is WY? Okay, so what we do know is that the diagonals of a rhombus are perpendicular and they bisect. So this is a right angle, and WY is split into two equal pieces. Because the diagonals are perpendicular bisectors, if this measure is 3, then the other side has to also be 3 because the diagonals bisect. This gives us a nifty little right triangle, and if we can figure out x, what this side is, we can double it and get WY. So to find that, we're going to use the Pythagorean Theorem, because it is a right triangle. And the legs are x and 3, so x squared plus 3 squared equals the hypotenuse, which is 5 squared. That is your equation. Do the exponents first. 3 squared is 9, 5 squared is 25. Subtract 9 from both sides, you get x squared equals 16. Take a square root of both sides. 16 is 4 times 4, so x equals 4. So if x is 4, then WY is twice that. So the length of WY has to be 8. And again, the theorem we had to use is that the diagonals are perpendicular and they bisect. That's what allowed us to do that. All right, I'm going to draw a line here just to keep my work tidy. Okay, what is the measure of angle RPS? Okay, so we're looking for the measure of angle RPS, which is this one. And we know that given a rhombus, that the diagonals bisect the angles. So this angle and this angle are going to be the same as this angle and this angle. All right, so we're looking for RPS. So RPS is this one right here. That's what we're looking for. So the diagonals bisect each other. And we also know that opposite angles are congruent. So if this one's 70, this one's 70. So now I have a triangle with two congruent angles. So we're going to use triangle Sum Theorem and say that these add up to 180. I'm going to call this one x and that one x. So x plus 70 equals 180. Triangle Sum Theorem. And I'm going to solve for x. So x plus x is 2x, plus 70 is 180. Subtract the 70 over, you get 2x equals 110. So x has to be half of that, which is 55 degrees. That means that the measure of angle RPS is 55 degrees. And we use the fact that the diagonals bisect the angles in the corners. That's how come we got these four the same. And then triangle Sum Theorem. Okay, We are trying to find QT, which is this one. And let's use our theorems. This is a rhombus, so the diagonals bisect, which means QT and TS are the same. That's kind of interesting, isn't it? So QT and TS are the same. They've given us 3y minus 1, but this 3y minus 1 applies to this side right there. So what do we know about rhombuses? We know that diagonals bisect. We also know that all four sides are congruent. That would be the definition of a rhombus, which means QP, QR, RS, and PS are the same. So if I'm looking for y, which I need to get that length, I can use those two expressions to make an equation. 3y minus 1 has to equal 2y plus 3 because all the sides of a rhombus are congruent. So I'm going to subtract 2y over to the left, add 1 over to the right, y equals 4. Now that I've got y, I can use the fact that q to s is 5y minus 4. So qs equals 5 times 4 minus 4, which is 20 minus 4 or 16. Now, because the diagonals bisect, QT is half of that. So QT is half of 16, which is 8. So sometimes you have to use a different property to get the y, and then you can use it in the expression that applies to what you're finding. So all three of these are problems you will see again, and using old theorems as well. Okay, number 2. Is each parallelogram a rhombus, a square, or a rectangle? Now, when you get these questions on your homework, you always want to pick the most specific name possible. So a rhombus, a square, and a rectangle are all parallelograms, but we're looking for something more specific than that. All right, let's look at this first figure. It is a parallelogram. So because this is a parallelogram, which they told us right here, it's a parallelogram, we know that the diagonals bisect. So GL and LJ are the same. HL and LK are the same. Okay, so because all four of those are the same, the diagonals are congruent, which makes this a rectangle. Now the question is it a rectangle or is it a square? The problem is that a square is a type of rectangle. A square does have diagonals that are congruent and bisect, but a square has the additional property that all four of the sides are the same. We don't have that information here. We don't know anything about H, G, and JK. All we know is that the diagonals are congruent and they bisect. So rectangle is as specific as we can get without additional information. Okay, let's look at B. All right, we know this is a parallelogram. And so parallelogram means left and right are parallel, top and bottom are parallel. We also know that in a parallelogram, the diagonal becomes a transversal and alternate interior angles are congruent. So if we're working with this transversal, then the left angle there has to be the right angle here. So this angle and that angle must be the same. Using the top and bottom parallels with the same transversal, we can see that the other sides are the same as well. So looking at this, We do know that it's a parallelogram. We also know that we have one diagonal that bisects congruent angles. And we have a theorem that says if you have a parallelogram and one diagonal bisects the angles, it must be a rhombus. And again, that's one of our theorems. We can't get any more specific than that because a rectangle and a square both have 90-degree angles in the corners, and because we don't know that U and W are 90 degrees, we can't conclude it's a rectangle or a square. Rhombus is as far as we can go. All right, let's do number 3. It says in parallelogram A, B, C, D. Now you're going to want to draw these, and it's really easy to draw a parallelogram. I usually just draw a horizontal line about 2 inches, and then I go up and to the right and draw another horizontal line that's about 2 inches and connect the ends. And that'll give you a pretty decent figure to label. Okay, this is A, B, C, D. And it is a parallelogram. Okay, so let's mark these parallel. And it says A to C. Okay, we're talking a diagonal here. A to C is 3W minus 1 in length. And then B to D, which is the other diagonal, is 2 times W plus 6. It says, what must be true for ABCD to be a rectangle? So for this to be a rectangle, what needs to be true about what we know here? Well, for it to be a rectangle, the diagonals must be congruent. So the part of the question got chopped off, which is what value of W will make the parallelogram a rectangle? What value of W will make the parallelogram a rectangle? Well, if it's a rectangle, the diagonals are congruent, which means that 3W minus 1 has to be equal to 2 times W plus 6. That has to be true for it to be a rectangle. So let's solve for W. Distribute the 2, so 2W plus 12. Then we're going to subtract 2W over to the left. We're going to add 1 over to the right. We get W equals 13. If W is 13, the diagonals are congruent and it's a rectangle. So you can see how definition focused this section is going to be. You will want to refresh yourself on your notes before you start your homework so that you remember all the different theorems for each shape. That's all I have for you today. Have a good afternoon.